Signals and systems. Inverse Laplace transform of 2s plus 5 divided by s square plus 5s plus 6s. We have to take the partial fraction for the given question. We will get the a and b value as 1. After we have to take the inverse Laplace transform and we will get the answer as f of t is equal to e power minus 2t plus e power minus 3t. A function having frequency f is to be sampled. The sampling time t should be. Sampling frequency must be more than 2f. So the sampling time is less than 1 divided by 2f. Which one of the following rules determine the mapping of S-plane to Z-plane? Right half of the S-planes maps into outside of the unit circle in Z-plane. Similarly, left half of the S-planes maps into outside of the unit circles. Imaginary axis in S-planes maps into the circumference of the unit circles. The above given rules are used to determine the mapping of S-plane to Z-plane. So, the answer is all of the above. Assertions. The conditions under which it is possible to write Fourier series of the periodic functions are called Dirichlet conditions. Reason. If f of t is equal to minus f of minus t, it is referred to as odd symmetry. Both assertion and reason are true, but reason is not the correct explanation for assertion. If f of t is odd functions, f of j omega is equal to 2 into integral 0 to infinity f of t into sine omega t into dt. F of t is odd functions. F of j omega is a even functions. So the answer is false. If h of z is equal to 1 plus z inverse divided by 1 minus pi by 6 into z inverse plus 1 by 6 into z inverse square, the poles of h of z are at. First, we have to take z inverse and z inverse square as 1 by z and 1 by z square. After, we have to cross multiply it. And the denominator z term, we have to equal to 0. We will get the poles. So, z is equal to 1 by 2 and 1 by 3. ROC of sequence x of n is equal to 3n u of n plus 4n u of minus n minus 1. We have to take the Fourier transform for the given questions and we will get the answer region of convergence as 3 less than modulus of z less than 4. If f1 of t is equal to f1 of j omega and f2 of t is equal to f2 of j omega, then a1 f1 of t plus a2 f2 of t. The RHS of the linear system is a1 f1 of j omega plus a2 f2 of j omega. The trigonometric Fourier series of an even functions of time does not have the sine terms because the trigonometric Fourier series of the even functions of time have DC terms and cosine terms. It does not have the sine terms. System represented by the equations y of t plus 4 plus 2y of t plus x of t plus 2 is. For the given equations, it is casual because the output of the time depends only on present and past value of their input signals and it is linear since there is no constant terms in the given equations and it is also time variant since there is no any time factors in the given equations. So the answer is all of the above. Thank you.